Hey guys, ready for lesson 2. So yesterday we reviewed the sets of numbers and we looked at natural numbers, whole numbers, integers, as well as rational numbers. And today, of course, you can see by the title of the lesson that we're going to look at irrational numbers. And I'm going to make sure before I post this one that it's clearer than the first one that I gave you yesterday. So apologies for that. So you can see that we're dealing with irrational numbers. And this isn't important right now, but the letter that we use to represent irrational numbers is actually called Q prime. And I know that seems a little weird, but my thought is that when you deal with the rational numbers and the irrational numbers, so Q and Q prime, all of those numbers, those two sets, as well as the ones that are in the rational numbers, make up the set of real numbers. So when we're looking at irrational numbers, these are numbers that cannot be written as a fraction, and we know that because numbers that can be written as fractions are rational. So this set includes all non-terminating and non-repeating. We looked a little bit at those yesterday. We just said that they weren't rational. Decimals as well as pi. That's kind of the way that I do pi, which sort of looks like a part fraction with a denominator, and the square roots of all non-perfect squares. We looked at perfect squares yesterday. So in this next section we want to look to identify if the following numbers are rational or irrational. So of course 72, we know that's natural, as well as a whole number, an integer, and rational, so it's rational. So we have to make sure, if possible, that we simplify these. So the square root of 64 is 8, which is also a counting number, therefore a rational number. 48.59, that's what type of decimal? Terminating decimal, and therefore again is rational. All of those can be written as fractions. And then we have negative 33, which is also rational. And here we get to the square root of 41. So we can do two things with that. We can look at it and know that 41 is not a perfect square, or we can type it in our calculator. I don't know if you can see that very well. Square root of 41, and you can see that it fills up my screen, which means that this will be a non-terminating, non-repeating decimal, and therefore is irrational. And then last but not least, this still follows the parameters for a rational number. It's written as a fraction. The numerator and denominator are integers, and the denominator is not 0. So move that up for the next one. A non-perfect square is any rational number whose square root is not a rational number. So what we're looking for now is a list of the first 20 non-perfect squares, and so we'll start with 1. Well, we looked at that yesterday. The square root of 1 is 1, so it is a perfect square. 2, so basically what I'm going to do is I'm going to count, and I'm going to skip all of the perfect squares. So 2, 3, 4 was next on our list yesterday. So 5, 6, 7, 8, skip 9, 10, 11, 12, 13. What's the next one I'm going to have to skip? 16. And I think that's it. And the last one, today's a fairly short lesson. Use your scientific calculator to determine an approximate value for the square root. So what we're going to do here is we're actually going to round it. So we're going to change the square root from being an irrational number to rational. So I type in the square root of 5,749, and it says round to 1 decimal place. And so what that means when it says 1 decimal place is we look at the second digit after the decimal. If it's a 5 or higher, then it bumps the previous one, and if it's between 0 and 4, we just leave it as it is. So my calculator says 75.822. So because of that first 2, I'm going to go 75.8. So when we take 75.8 and we square it, I get 5,745.64. So you can see obviously it's not exact because we're changing its square root from an irrational number to a rational number, but it's close. So if you want for these ones, you can convert them to decimals. So square root of 4.5 is 2.1. Square root of 45.83. Now this one, it says 6.76. So because of that 6, that means that I need to bump that 7 to an 8. And lastly, the square root of 333 will be 18.2. So for tomorrow's lesson, I'm going to talk about some quizzes that I'll post. So make sure you listen to that. And feel free to ask me any questions if you have any during the assignment. And we'll talk to you tomorrow. Have a good day.